Alright, welcome back, llamas. This is block 2 from topic 11 on page 355. You may need to pause the video to have people finish writing, but don't take too long writing and pausing it. So, the first thing we're going to look at is that table on page 355. And so we have genders, and obviously we're using a coin. Heads is going to represent girls, tails is representing boys, and they flipped it 20 times. 8 of them landed on heads and 12 on tails, and they found the mean or the average of those. So the first question, number 1, asks, what is the theoretical probability of tossing a coin and getting heads? Okay, well, what is the theoretical probability? Theoretical is dealing with the object. What is the chances of each side happening? There's 2 sides of a coin, so the chances is 50-50. So my theoretical probability is 50% or 0.5. Then number 1 also asks, explain what this probability means. Okay, well, what does it mean? In this scenario, 50% should land on heads 50% of the time, and 50% of the time it should land on tails. So we should write something similar to that. We could shorten that up. Let's see. This means you expect to get heads 50% of the time you toss a coin. That first sentence is fine if you just want to copy that down, that first sentence. Okay. Number 2 says, based on the results in the table, what is the experimental probability of tossing a coin and getting heads? The experiment has happened. So I'm looking at this table for information. We're looking at getting heads, so girls. It's 8 out of 10. So what is my experimental probability? What percent? I got 0.4 is the mean. The percent would then be 40%. Okay, number 3. What could be the difference between theoretical probability and the experimental probability? What could be the difference? Okay. One explanation is that 20 tosses are not enough to develop an experimental probability. That is why it was a little different than 50-50. If they would have done more tosses, it would have gotten closer to 50%. So that is the difference. All right, flipping to problem 4. Problem 4 you're going to conduct after this video is ended. I'm going to do an example of how that would go, so you're not writing any of this down on number 4. I'm doing my own example. My trial is going to have 100 times. If you notice on number 4, you're doing a trial that says 50 times. And you're flipping a coin. We've established girls is heads and boys is tails. If you need to write that somewhere on number 4. Because after this video, you'll get a coin and you'll be flipping it 50 times and recording it into these tables. Then you have a smaller table there. Let me go to that slide. You have a smaller table off to the side here of where you're going to calculate the total number of males, total females, and finding the percent of both of them. Okay, so you're watching up here, not writing any of this down right now. Alright, so this is a table of my first 20 trials. I need to do 80 more, so I have 100 trials. And I want to see if it got close to my theoretical probability of 50%. So, looking at this first animation, they flipped it, landed on tails. They added one to boys, landed on tails again, added another to boys. Landed on heads, added one to girls. Landed on heads again, so added one to girls. Another to girls. Another, and oh, okay, there it's going crazy. So they did that 80 more times, so now I have a total of 100 tosses. Alright, so we got 52 times it landed on heads, which represented girls, 48 times on tails, which represented boys. Is this closer to my 50-50 theoretical probability? Yes, it is. Okay. Still not writing any of this down yet. So to calculate the mean, this is how you would calculate it. You can see this chart on your next page above number 5. It's already filled in for you. And they calculated the mean for you. 52 out of 100 flips. I got a mean of 0.52 heads per toss, which represents 52%. 48 over 100 is 0.48 tails per toss, and that represented 48 tosses. So those are the averages for each of them for 100 tosses. Okay, so now I'm moving to number 5. And it says, are these means closer to the expected results, the theoretical probability? So are these closer to my theoretical than they were when I just had 20 tries? When I had 20, I'm pretty sure it was 20 and 60. 40 and 60. So do you feel these are closer to that 50-50 theoretical probability? I do feel like they're closer. They're closer to that 0.5. Okay, number 6 says, why didn't the numbers match the theoretical probabilities exactly? Okay, they do not match them exactly. There's many factors that could play a point, but basically, we need a larger number of trials to get the exact theoretical probability. So if you want to write my shorter version I just read aloud, I said you need a larger number of trials to get closer to theoretical probability. You need a larger number of trials to get closer to the theoretical probability. Okay, moving on to number 7. I have a new chart here, and it looks like they have now flipped 5,000 times total, and they calculated the mean. And the first question, number 7, asks, are the experimental and theoretical probabilities close? So our theoretical was 50-50. Is 20% and 80% close to 50-50? I do not believe they are. No, it is much more likely that you would get tails when you toss the coin than heads. All right. Then number 8, what could explain this result? We have talked about this with coins before. that it is more likely to land on tails for a certain aspect, if you recall that aspect. So a couple things could have gone wrong. One, you might have not been tossing it fairly. You might have put some force behind it, so you weren't tossing it fair. Or one side is heavier. The head side is heavier, so it is going to be landing face down, making tails be visible. So the coin is not totally fair. So you can write one human error in tossing, because you made some error possibly in tossing. And two, one side of the coin is heavier. Alrighty, moving on to 9 through 13. Okay, I'm pretty sure yours pictures has letters underneath them, so you're writing the appropriate letter that matches. I want you to pause the video and write what you think the answers are for this scenario, and then we'll go over them. Alright, so looking at number 9, it says there is a 50% chance probability of rain today. So which object could I use to mimic a 50% probability of rain today? Well, what is my options that could happen? It could rain today, or it could not rain today. That's two options. So which of these objects has two sections that's useful? That would be the coin. Okay. Next, Sarah has an equal probability of being assigned one of six different lab partners. 1 out of 6 different lab partners. So I need 6 sections. The object that has 6 sections would be the die. So I'm pretty sure that's B in your case for number 10. Number 9 was E. Now 11. Janelle chooses at random from 10 different paint colors. Okay, how many objects is she talking about? 10 different paint colors. I need 10 sections. So, which one has 10 sections? 1, 2, 3, 4, 5. Looks like this guy right here has 10 sections. So for number 11, you should have put C. All right, number 12. You have a 1 in 4 chance of getting the correct answer on a multiple choice test. Multiple choice test, yes. 1 out of 4. Okay, so which of these objects has 4 options? That would have to be these little bad boys here, whatever they're called, little chips. It is D on your paper. And 13, Marcus has 20% chance of making the team. Okay, that one might be a little confusing. I need to know how many sets of 20% is in 100. 2, 4, 6, 8, 10. That's 5. So I need 5 sections. And this little spinner here has 5 sections. So that is A for your paper. All right. So now you're going to partner up with people at your desk. You're going to work on problem 4, flipping coins, recording your information, finding the percent of male and female, and you're also doing problem 14. Don't forget about 14. When you're done with all that, you'll have some more practice online that you can work on. Have a great day. Thanks for listening. Like, subscribe, hit the notification bell, and peace out, llamas.